We're going to move on now to Mika Dumont and Kendra Havens, and they're going to talk about improving your productivity with Roslyn analyzers. Hi, guys.
Hi.
That is
Hi,
not
Robin.
easy to say quickly. Roslyn analyzers.
It's a tongue twister.
Yeah.
Cool.
How are you?
So good. How are you?
Excellent, thanks. Take it away.
Yeah, okay. Let's go ahead and get started. I have some slides. I think they might be shared. So yeah, this is improving the Roslyn analyzers. I'm Kendra Havens. I'm a program manager on .NET and Visual Studio. And Mika?
And I'm Mika Dumont, and I'm a program manager on .NET and Visual Studio.
Cool. Same thing, same team.
Yeah, seriously.
So Katie just showed this. Wow, what cool improvements. Especially excited about a lot of the stuff that her team in Telecode is doing. We always want to show the Visual Studio preview. That's what we'll be using today with all of our demos. So check out 16.9 preview to get some of the latest features. There's environments in the cloud, AI assisted productivity, so many cool things. We're going to focus in on the Roslyn analyzers. We're just going to give an overview of what's new, go through some of the latest code fixes and refactorings, go over some of the .NET 5 SDK analyzers specifically, and then Mika's going to show us how to write a Roslyn analyzer. So before we get into it, Mika, what is Roslyn?
Well, Kendra, I thought you would never ask. So Roslyn is the code name for the C# and Visual Basic compiler, where we built an open source API surface so that any developer can write really smart code-focused tools and technologies. And some of these tools and technologies are also known as analyzers. And analyzers is basically a tool that will run analysis on your code as you type, and it will report diagnostics in the editor. And these diagnostics will manifest as squiggles. And so if you're ever in Visual Studio or VS Code and you see those squiggles, those are analyzers running in the background. And analyzers also surface a light bulb or a screwdriver suggestion, also known as a code fix or refactoring. So the best way to understand what an analyzer is to actually see an example of one. So if we switch over to my screen over here, yes. So this is an analyzer. And analyzer has two parts. It has the squiggle letting you know that there's a violation. So that's going to be part of the diagnostic. And then it has the code fix. And so this will fix that violation. If we take a closer look at my error list, you can see that I have these analyzers running in the background. And they're reporting violations in my code. And analyzers also have different types of severities. So we have the error severity, the warning severity, and then the suggestion or the information severity. There's also a fourth severity called hidden or silent, but that won't show up in your editor or in your error list. And I'm going to talk a little bit more about that later on. So using my error list, I can go ahead and navigate to all of these code violations. And so this analyzer is offering me a code fix to simplify this conditional expression. This did start off as a single Boolean, but then it got pretty complicated. So I'm going to go ahead and apply this code fix to simplify this conditional expression. And speaking of simplifying code, we also have this analyzer, and it's offering me a code fix to remove this redundant equality operator. So that's pretty sweet. And hopping over to this one here. So analyzers can also surface a less invasive like UI. And so notice here I have these dots, and these are suggesting me that I can go ahead and fix this up. And so one of the latest code fixes that we added was pretty much simplifying this new expression. And analyzers, as I mentioned earlier, can have the hidden diagnostics. So they won't show up in the editor or the error list, but you will see them as represented by a screwdriver or a light bulb in the margin. So if I invoke the screwdriver over here, I have all these different refactoring options. For instance, I can select extract space class, which we just added. So I can go ahead and select different members from this class, and I can transfer it to a new base class. So that's pretty cool. And we also added another refactoring. So this one is inline method. So if I want, I can go ahead and replace usages of a static, instance, and extension method within a single statement body. And I have an option here where I can either keep or remove the original method declaration. So that one's pretty cool. So Roslyn doesn't only provide code fixes and refactorings. Here's a little more on how it hooks into tooling. So notice all of these XML comments I have over here. See, lots of them. These now have style support. So Quick Info will now display a clickable link, bullets, and italics. And we also have the inherit doc tag to inherit XML comments from base classes, interfaces, and similar methods. So let's say I want to add that tag over here. I can go ahead and add it. And so now if I hover over this class, it will now inherit those XML comments, keeping my XML comments in sync without having to copy and paste duplicate XML comments. So I don't know if you noticed, in my solution, I have all of these adornments. These are inline parameter name hints. So these are built into the default tools of Visual Studio. They are off by default, so you will need to turn them on in Tools Options. And you would just select these. And in 16.9 Preview 1, we added a bunch of customization options here. And we also added inline type hints for variables with inferred types and for lambda parameter types. And let's say the UI is a bit too distracting for you. You can go ahead and deselect those options, but you can keep the displays all hints while pressing Alt-F option on. And so what that will do is it will just make these name hints magically appear when you press Alt-F1. Ooh, ooh-wee. So I like to have them on because I find them extremely helpful. So I'm going to turn those back on. And this was built actually by one of our very own interns this past summer using the power of Roslyn. And a lot of these code fixes and refactorings that I actually just demoed are built by the community. We get tons of contributions. Kendra, how many PRs did we get in the last sprint?
We got 89 community PRs in the last sprint.
It's wild.
Yeah.
So it's pretty cool. So anyways, if you're still not impressed by Roslyn and all the smarts that it provides in the editor, Roslyn also powers IntelliSense completion. So a lot of people were really big fans of regex completion. I can go ahead and open IntelliSense by typing Control Space. And here I have my different completion options and an explanation of what each of these regex characters mean. And so since people love that, we added that for date time strings and time span literals. And what I really love about this is that it gives you examples. So it's just a really nice inline experience without having to go on the interweb and learn how to write date time format and so on. So that was a quick overview of Roslyn and how it powers our productivity tools. And now Kendra is going to talk about Roslyn analyzers in the .NET 5 SDK.
Yeah, so if we switch to my screen, I've got a couple new things to show. So in .NET 5, we are including an entirely new set of analyzers that you haven't seen before. We've actually kind of been holding these back for a few years because they might appear and have new warnings in existing code. So we didn't want, for everyone who had warnings set as errors, we didn't want to cause source breaking changes and stuff. Let me show you a few of these and then talk about how we set it up so that we can avoid any upcoming issues of extra warnings appearing in pre-existing code. So this one is warning when an expression is always true or false. It's comparing a date time, which is a struct, and checking if it's null, which is actually always going to be false. So the recommendation is to either delete this line or actually intentionally pass in datetime as a knowable object. So now you get a warning for it. The next one, probably super concerning. When you're allocating a stack inside of a for loop, that's not best practice. We always want that to be outside of it. So you're now getting a warning anytime that occurs. And our recommendation is to just pop that out of the for loop, and then the warning will disappear. So this next one, you want a read-only span of characters, and you're getting it from a string, and you're accessing what substring you want using range-based indexers. So that is actually creating extra data copies in the background. So what you want, and we have a code fix for this, is as span in between there. So that will be a more efficient way to access that string and avoid extra memory usage. The next one is, so this is super common, especially for students. When you catch an exception, you have a variable name, and when you catch a ball, you throw it back, but you expect you need to throw that same variable name. You actually don't need to, and if you do, you're actually erasing some of your stack detail information. So we have a code fix to just throw. Don't include the variable name, and then you can clean it up a little more, take out the unused variable, and just catch the exception type. So as you might realize, a lot of these occur in code that already exists. And we don't want to cause extra warnings when people aren't ready to kind of deal with them and make those code quality improvements. We want it to be there when you're ready for it and when you want to work on that. So what we've introduced is analysis levels. So by default, all of the .NET 5 SDK analyzers appear in your .NET 5 project, but you can adjust the analysis level. So analysis level 5 correlates with .NET 5. If I bumped it down to 4, it would correlate with .NET Core 3.1. And here's a little bit of what that looks like. So another benefit with kind of decoupling what analyzers you can get with what SDK and making that independent of what your project is actually targeting is you can have a project that's targeting .NET Core App 3.1, but still get analyzers from the very latest ones from .NET 5 SDK. So you can set analysis level 5 in a .NET Core App 3.1. Pretty cool. And in that same theme, we're always adjusting how often you see certain analyzers. So all of these are also, all of these SDK analyzers are also configurable with editor config. So as Mika showed, you can set different severities. So right now it's a warning. And if I go over to my editor config and put in, hey, how about I just want that to be a suggestion? So instead of a green squiggle, when I go back here, it switched to those 3 dots. So you can put this silent, you can even bump it up to an air. It's a lot of configuration. So that's .NET 5 analyzers. Yeah, in Visual Studio 16.9 Preview 1.
Woo woo!
Yeah, pretty cool. So Mika, do we have enough time? Do we need to speed through a Roslyn analyzer template building kind of thing?
Yes, let's do it. Okay, so hopefully we'll have time to just run through how to create a Roslyn analyzer. Today, if you want to write an analyzer, you do need to use the syntax tree API, which basically has 2 components to it. It has the syntax tree, which is a high representation of your code. This includes all your comments, your white space, and line trivia. And then we have the semantic model, which basically contains any information related to the meaning of your program and the symbolic information that you need. So the way that these 2 components interact are through a question-answer model. So from the syntax tree, let's say you have an array and you want to figure out what type the array is, you ask the semantic model, and the semantic model will return an answer to you. Okay, so what we're going to build today. So we're going to create an analyzer that identifies missing braces in a statement that is not enclosed in a block that has curly braces. And then we're going to create a code fix that suggests you add braces. So switching over here, the very first thing that you will need is the Visual Studio. Okay, so the first thing you need is the .NET Compiler Platform SDK. So you can do that through the Visual Studio installer by selecting Modify, waiting that to load. And if you scroll down, you can just select this Visual Studio Extensions Development Workload. And I can go ahead and just expand this, and there is my .NET Compiler Platform SDK. So we got that already installed. Next, you want to launch Visual Studio. And we were really nice, and we created this template for you. So you can go ahead and use that. And I think the template, it has a default boilerplate for an analyzer and a code fix that makes all types uppercase.
Very useful code fix. Just capitalize everything. Have all your types yelling at you.
Very useful. All right. And I think we got it. And so then I'm going to create a new project. And to get to that template, I just like to filter it. So I'll just type out analyzer to get to it quickly. And we have two options. We have Analyze with CodeFix for C# and one for Visual Basic. I'm going to choose the C# version. And I'm actually going to X out of this because I already have one open. All right, so this is pretty much the boilerplate. This is the template. It has 5 projects, which you can see in the Solution Explorer. And the only code I've added to this so far is really just these few lines here. This is all part of that boilerplate analyzer that makes your letters capitalized. So the most important part is to write the diagnostic, and you would do that in the brace analyzer file. And so this file contains the analyzer implementation that reports a diagnostic. And the only thing that really matters is this initialize method down here. And basically up here, the title, the message, and the description is for your analyzer. And I already went ahead and updated that. And I added .NET Conf 2020, so we can test it and make sure it's working. And we know it's working. So yeah. And then another thing and then we have the diagnostic descriptor rule, which is where we define what our rule is. So the rule is where you have the diagnostic severity, which you can see over here. And that's where you just determine how you want this to manifest in the editor. So those are like the red squiggles, the green squiggles, the little dots. And it's also for the error list too, like how you would see that too. So I'm going to keep it as a warning. And then I'm going to scroll back over here. And so that's that. So I already have code ready to go just because we don't have too much time here. So let me quickly add that. And then I think I'm missing a brace. Okay. So pretty much what the initialize does is it gives you a context, which is all the information you can access at this point. And what you're going to do is register a callback in this function. So when the compiler hits a certain node or a token, you can specify it's going to call that callback. And if you want to explore, I don't have too much time to just go over the syntax visualizer here. This will help you explore the syntax tree a bit more, which will help you create this initialize method. And then let's move on real quick to writing the code fix. So this code fix will add the missing braces. And the code fix takes in the diagnostic ID, which you can see here. And so this is the same ID that we created for our analyzer, and it will give that ID to the compiler. And so that's already hooked up by default. So we didn't even have to really do much there. And then we're going to just, again, really just update a few lines of code here. So taking a look here, I'm going to clean this up. So I'll just go ahead and add this here. And so this register code fix async, this is where we're registering our code fix. And then the add brace async is where we invoke the fix to add the braces. So I truly updated, I don't know, under 20 lines of code in only 2 files. Now we are ready to test this analyzer. And so before we do, make sure the startup project is the Brace Analyzer v6. And then you're going to go ahead and just press F5. And so what it's doing when you press F5, it will open an instance of Visual Studio that already has my analyzer installed in it.
So you're launching Visual Studio from Visual Studio?
Yes.
Whoa, whoa, whoa.
It's cool. Crazy. Yeah, it's really cool. And it's the best way to test that if your analyzer works. So I already created a console app over here. And then we can just wait for it to load. And as this loads, if we see a squiggle in there, that means the analyzer works. And then if you see the light bulb and the code fix, we're doing great. So let's wait for that. Okay. So, still loading.
Yeah, it's just gotta run the initial analysis. Oh, hey.
Ooh, okay. And you see that this shows you, it's from .NET Conf 2020. So this is our analyzer working. And then we also have the code fix to add the brace. Woo! And that's the tea. So that was an overview of the analyzer and the code fix. It was really simple, like really just adding under 20 lines of code into 2 files. And it's really not too complicated to write these things. And you can even, as a next step, build your entire solution, create a NuGet package, and you can just publish that to NuGet so anyone on your team can then use your analyzer that you just created. And yeah, so so hopefully you can go out there. Thanks for joining. Hopefully you can go out there today, use Roslyn analyzers, try to build some cool analyzers with the syntax tree API, give us feedback. You can also follow us on Twitter and ask the team questions on analyzers and let us know about the awesome analyzers you're building and just spread the Roslyn coolness.
I like it. We'll see you in the open source.
Oh my God, that was so cool. That was so cool. I think we have time for a couple of questions.
Excellent.
So the first one is from Jim Woolley. Has questions about updating analyzers to .NET 5 and using C# 9 records.
I think we know our default templates for Roslyn analyzers don't yet work with .NET 5. I actually think we were debating if they still required a .NET framework dependency, and we had it checked up on that. Did I follow up with Sam on that? I'm not sure. I think we're not too let's see, motivated on that right now, but that's probably a good issue to open on our repo that we could possibly move or encourage or change the template formats to use some of the latest features. And we'd probably get a lot of performance benefits out of it. So we'll have to look at it.
Cool. Nathan wants to know what refactorings and analyzers are available for VB, because we've seen a lot of C# today.
So a lot of them actually work for VB unless they are language specific. So a lot of these that I showed are going to work for Visual Basic as well.
All right, awesome. Thanks guys so much for that. I think we're going to move along here. I'm done with my part of the show. Thanks for having me. Good to see everybody. And I'm now going to turn it over to Myra Wenzel.